Hi students, now we're going to discuss line and planes in space. We know that equation of a line in two-dimensional picture, it was y equal ax plus b. And we found that this y equal ax plus b or ay plus bx plus c equal to 0 is an equation of plane in three-dimensional figure. Equation of a line in space is different than the equation in two-dimensional. So how do we find it? Suppose you have a line L passing by a point P0, which is fixed given, and parallel to a direction vector, which is V. So we know that if we pick any point P on this line, this P is moving on the line. Because it's parallel to V, we can say that P0P is parallel to vector V. Because it's parallel, so we're going to find first of all the components of P0P. P0 is given, and we said let P has coordinates x, y, z. So you're going to get x of P minus x of P of 0. So x minus x0, y minus y0, z minus 0, parallel to vector V, whose the components are V1, V2, V3. So since they are parallel, we're going to put the ratio of parallel. So we say x minus x0 over V1 equal y minus y0 over V2 equal z minus 0 over V3 equal to a specific ratio t. So now if you want to find x, so x will be cross multiply V1t plus x0, y will be V2t plus here I have y0 by mistake, z equal tv3 plus z0. So this is called the equation of parametric equation of a line. So to write an equation of parametric equation of a line in a three-dimensional, so we need to have a particular point which is x0, y0, z0. We need to have a parallel vector to that line whose components are v1, v2, v3, where t is any real number which is the ratio of parallelism. This system is called the equation of linear equation in three-dimensional. So I need a particular point, x0, y0, z0, and I need a parallel direction to a vector v whose coordinates are v1, v2, v3. So this is called the parametric equation of a line. So let us go to problems. Find the parametric equation of a line passing by point A and parallel to vector B, like this picture. Because it's passing by a point and parallel, so I can write it directly. X equal x of A is 1, y equal y of A is minus 2, z equal z of A is 3. Now I want to add the components of the vector, so minus 2t plus 3t plus 1 times c. You can put any variable you want, certainly t belongs to R. Number 2, find parametric equation of a line passing by 2 points. Because now it's given 2 points, so I can find the direction vector of the line. The direction vector, it's nothing than AB. You know, if you have a vector AB, for example, here you can have infinitely many vector equivalent to it, parallel and same direction. So I can use that of vector AB. So let me use that of vector AB. So the component will be 0 plus 1. 1 minus 2 minus 1, 2 minus 3 is minus 1. And concerning a particular point, you can pick either point A or point B. Both will lead to the same answer. Same thing. So I'm going to use B. So x will be 0 minus t. Y will be 1 plus 2, x will be 0 plus t. Y will be 1 minus 1 times t. Z will be 2 minus t. So I'm going to repeat that AB is the directed vector, which is called what? V, as we did up. Okay, like here. The third example here, find the equation of a line passing by the midpoint of AB. You know, if you want to find midpoint, so you add the boundaries over, you add the coordinates over 2. So 1 minus 3 over 2 is minus 1. 3 plus 5, 8 over 2 is 4. 4 minus 2 minus 1. So I have the particular points that we have, and parallel to that line, because it's parallel to that line, it has the same directing vector here. The directing vector here is 1. As you can see, 1 minus 1, the coefficient of t, and minus 1. So I write minus 1 for minus 1 and t minus t for x, y, z. Relative position of two lines. Either two lines are parallel, as you can see, or coincide in a point, or they are skew. What does it mean, skew? As you can see in this picture, the two lines are in the three-dimensional, they don't meet, no point of intersection. Most of the lines are skew because they don't meet. It's in 3 dimension. It's very difficult for two lines to meet. So either parallel or skew or intersecting lines. So now case one. If given two lines L L prime, either case one parallel or coincide, how do we know? Suppose you have these two lines. If parallel, you must have V1 over because if parallel, they have a parallel directing vector. So V1 over U1 must be equal V2 over U2 equal V3 over U3. In this case, either parallel or coincide. In the case to be coincide, we pick any point here, for example, X, A, Y, A, Z, A, any point. You try to replace it here. Okay, you try to replace it in L prime. You have the point X, A, Y, A, Z, A. Okay, you try to replace it. If it satisfies this equation, we're going to see in an example after, it means that it is coinciding. If you replace X of A here, if you replace X of A here, Y of A here, Z of A here, you're going to, if you get the same T prime for the three, it means the lines coincide. So let us take examples. Study the relative position of these two linear equations. So I have these two, all right? So first of all, I'm going to check if parallel or coincide. So I say -6 over 3 equal -2 over 1 equal 4 over -2. Yes, all are equal to -2. So either parallel or coincide. So we pick a point in L, which is 2 minus 1 is 3. I want to check if this satisfies this equation. If you replace here x by 2, what do you get? T prime half. If you replace y by -1, you're going to get T prime is also half. If you replace z by 3, as you can see here, if you replace by 3, you're going to get also T prime is half. Since T prime is the same for all, so it means that the two lines coincide. The second example, okay, so here -6 over 3 equal -2 over 1 equal 4 over -2, all are equal to -2, either parallel or coincide. So I pick a point here in the first line, 2 minus 1 is 3. I try to replace it here too. If you replace it, T prime is half. If you replace it in the second one, -1, you're going to prime equal -half. So different. So directly, if one of them is not the same, so it means they are not coincide, but they are parallel because the two vectors are parallel. Now we're going to talk about intersecting or skew line. How do we know that if intersecting or skew? First of all, if the directing vector of the first is not parallel to the directing vector of the second, so not correct, you have one of them not equal, for example, I'll intersect or skew. So in that case, what do you do? We solve 2 by 2. We take the first two here and the first two here. We find T and T prime. So when you get T and T prime, two equation, two unknown, you replace here T and you replace here T prime. If you have the same value of Z, so it means the two lines are coincide. We're going to see they are intersect. If not, they are skew. We're going to take an example. Okay. Study relative position of the line following parametric equation. As you can see, the directing vector here, if you take 3 over 3, not equal -1 over -2, here -1 over -2. So it's different. So the lines are not parallel. So either skew or parallel. So now I take the first two, 2 plus 3t equal -1 plus 3t prime, 1 minus 2t equal 1 minus t prime. I have two equation, two unknown. You can put t and t prime on one side and take the number. In the equation you took in grade 10, you're going to get these two values. So what do? We take t equal to 1, we replace it here. So 2 minus 3 is -1. In the second one, if you put 2, -11 plus 10, so it's also -1, so they intersect. And the point of intersection will be what? You take the t, for example, which is 1, you replace it here. Or you take t prime, which is 2, you replace it here. You're going to get the same point because I started by x equal x, y equal to y, and we have z equal to z. So if you replace t here by 1, you're going to get 5 minus 1 and minus 1. And if you take t prime, replace it here, because here t prime by 2. So minus 1 plus 6 is 5. 1 minus 2 is minus 1. Minus 11 minus 10 is equal minus 1. You're going to get the same point. So these two lines intersect along this point in the three-dimensional. Now, we're going to talk about another example where the lines are skew. If you take these two and these two, first of all, not parallel with the same condition. If you take these two, if you solve the system, you're going to get t is 1 and t prime is 2. Now you replace t by 1 here in the z, you're going to get minus 1. If you replace here t prime by 2, you're going to get 9. Since these two are not equal, so directly they don't intersect, they are skew. This is the way to replace. To finish from the first part, this is from a point S to a vector D. This is the formula. Suppose you want to find the distance from S to a line D. This is line D. So I pick any point on that plane. Okay, any point. You can, for example, if you have a line, this is 1, 3, 0. Here you have plus 0, for example, because I don't have a point. No need to write it. So what do? I'm going to find first of all sine theta. Sine theta is, this is the distance, right? The perpendicular is distance over norm of PS. Because I'm talking about distance, I put norm. So what will be D if you do cross multiply? It's PS sine theta. But I know if I do PS cross V is PS dot V times sine theta. I want it in absolute value, so I put it in absolute value. But PS sine theta is what? Is D. So if you replace here D instead of this one, so what will be the distance? It will be PS cross V, cross product over norm of V. All you need to know is to understand the formula, no need to find the proof. So the distance from a point to a line, from a point S to a line, is this formula, but be careful, you need to pick any point P on the line. And like this example, find the distance from S to that parametric equation. So first of all, I need to pick a point on the line, which is P. So 1, 3, 0, as we said. I need to find PS. This is S and this is P. So PS, it will be 1 minus 1, 0. 1 minus 3 is minus 2. 5 minus 0 is 5. What do I need to find? PS cross V, then the norm. From previous, the cross product videos, you know that PS cross V, you put component of PS, you put component of V, you do the determinant, I into product minus that product, minus G, this product minus that product, plus K, this product minus that product. You're going to get 1, 5, 2. So I want the norm of that one because I want the norm. So it will be square root 1 plus 25 plus 4 over norm of V. The V is the parallel vector. What are the components of V here? As you can see, 1 minus 1, 2. The coefficient of T over norm 1 plus 1 plus 4. So you're going to get radical 5. Okay. We're going to see you in the second video. In the first video, now we talked about linear equation. In the second video, I want to talk about plane equation. So see you in the same video, in the same title, but part 2. Let me remind you of the title. The title is Line and Plane in Space Part 1. Now Lines and Planes in Space Part 2. See you in the second video.